Aloha everyone and welcome to this micro lesson on solving one-step and two-step equations. But before we get there, I would like to do a little review of our order of operations. The order of operations is something that we need anytime we're doing any sort of math problems, whether we're simplifying or solving. It's the order in which we want to look at math and work through it. Hopefully you do remember what the order of operations is. If you don't, let's take a little trip down memory lane. So I remember. Oh, now it doesn't work. Here we go. So I grew up with the acronym PEMDAS. If you have a different acronym for that, that's totally fine. If you want to share it with me or with your neighbors, that's great. I had one that was something that started with a G for grouping. But I remember it as please excuse my dear Aunt Shelley. You might say Sally, but I have an Aunt Shelley, so I say Shelley. The P stands for parentheses. E is for your exponents. M is for multiply. D is for divide. Oops. A is for add. And the last one is for subtract. Now, when you're working through these, the order that you want to go is you want to start up here with your parentheses. Anytime you see parentheses, you're going to be examining those first. So start inside and work your way out. So parentheses are always inner to outer. Next comes exponents. We won't get to exponents for a little bit, but we will touch on them in the second half of the semester. After that comes multiply, divide. Now these things go together and we work them, left to right. And then also, some teachers say this, and I'm one of them, D also stands for to drop parentheses. Now this happens in a few different cases, and I will let you know when we get there. These ones, add and subtract, they are also done together, and you work them left to right. Wonderful. Let's go through and look at some of these problems. So there is a sheet on Schoology if you do not have it, and let's get going. The rest of you should have it in your packet. So get that out and turn to that. First one is solving one-step equations. And again, I want to go back and make sure that everybody's on the same page. So if any time in class you have a question, please just ask me and we will work it through. Make a note on your page, circle it, star it. If you want me to work it out on the board or next to you, I can. My goal is to eventually get everybody to understand math and really come to like it as I do. Math is amazing, everyone. So let's move on. So solving. The goal for solving is to find solutions. And we want to find all of our solutions. The way we do that is by isolating our variable. Isolating means that we want to get that variable alone by itself. So what we tend to do, or what I like to say to do, is we undo everything that's around the variable, starting with the furthest away and working our way closest to the variable. For these one-step equations, there's only going to be one thing in our way, so we're going to undo those things that are in our way. So I like to start with the first one here. My goal is to try to get v alone by itself. And as I look at this, we got a plus 8 going on over here. And always look at the sign in front. This sign, if there is none written, it's assumed to be a plus. So we got a positive 8 plus v. The way that you undo an addition by 8 is with a subtraction by 8. And if you're going to be subtracting 8 on the right-hand side of the equation, you have to subtract 8 on the left-hand side of the equation. That's all about maintaining that balance that we talk about. And this makes sense because a positive 8 and a minus 8 will cancel out. You'll be left with just 0 plus v. And 26 minus 8, if you don't have a calculator, you should absolutely get one. Hey, that's 18. And of course, 0 plus v is just v. If you have something and you add nothing, you're left with whatever that was. In this case, it's a v. At any time, you can always go back and you can check your answer out, and you do that with the original equation. If I were to replace the v with an 18, 18 plus 8 is absolutely equal to 26. Yippee, we did it. So our solution is v equals 18. V is the number that when you substitute it into the original equation will give you a true statement. 26 equals 18, 8 plus 18, that's true. The next one I wanted to do was number 5 here. Looking at number 5, our goal is to try to find the values for m that will make a true statement when we plug it in. We do that by isolating the variable. So this is another one of those cases where you got m plus 4. So you got an addition. So the way you undo addition is with subtraction. And if you're going to subtract 4 on the left, you got to subtract 4 on the right. Doing that, these ones again will cancel out to 0. So you're left with only an m on the left. And on the right, you got a negative 12 minus 4. A lot of students will get, or can get, tripped up with these signs. Try to plug it in as you see it. Here is a negative 12, and I am subtracting 4. Hit go, negative 16. Oh, I lost my calculator. Another way I like to look at this is by thinking about money. If I have on my credit card or something spent 12 bucks, I consider negative 12 as spending 12 bucks and negative 4 as spending 4 bucks. If I spend 12 and I spend 4, I spent a total of $16. There we go. The next one we'll look at is number 7. And very similar, the way you undo subtraction is with addition. So here I would add 9 to both sides. These ones would cancel out, leaving us with just our m. Negative 13 plus 9 is about negative 4. And if you go back in, negative 4 minus 9 is certainly negative 13. So the ones that I'm skipping, those are the ones that I'll ask you to do after the video. Cruising down, we'll look at number 11 next. So here, this is another one of our assumptions in math. If you have a number and a letter sitting next to each other, like this case we got 8x, the operation that's hiding between it is a multiplication symbol. So I think they're just saving on ink. They don't want to write that symbol every time, so that's one of our assumptions in math. So if it's sitting right next to each other, it's assumed to be multiplication. The way that you undo multiplication, its inverse is division. So let's take a look. Does 104 negative get divided by 8 nicely? Ha ha ha, negative 13 it does. The other thing I wanted to point out real fast is the multiplicative inverse will always get you to 1. So like when I see this 8x divided by 8, when I hone in on this 8 divided by 8, well 8 divided by 8 is equal to 1, right? So really what we got is a 1x. And if you got 1x, most people just say x. It's another one of those hidden things. If you ever got just an x in there, you got one of them. In this case, we were starting with 8 of them. If it's a 1, you don't have to write it. Cruise on down to 13. So here our variable is b. B is a terrible variable because it looks like a 6. It gets confusing. But we're going to roll with it. So here we got negative 6 equals b divided by 18. Well, the way we undo a division by 18 is with a multiplication by 18. Now here I can't really fit it in, but we're taking that negative 6 and we're multiplying it by 18. Ooh, we'll clear out first. 6 negative times 18. Come on. Negative 108. And again, you can say that these 18s cancel out, but that sounds a little funny. Really, they reduce down to a 1. 18 divided by 18 is 1. So we're left with 1b, or just b, equals negative 1/8. Awesome. So those are some of our one-step equations. Let's move on to our two-step equations. So for these ones, we're going to start with number 1. So again, the goal is the same. Our mission is to try to get a variable alone. Here our variable is a, so we're trying to get a alone by itself. Now we got some things going down here, man. The closest thing to a is that division by 4. And this is a fraction. After that fraction is a plus 2. So I said at the beginning of the video that when you're trying to isolate your variable and get it alone, you want to get the things that are furthest away from it away first. In this case, the 2 is the furthest thing from that a, because anytime I see a fraction, I think about it as a group. It is this fraction stuck together, and then a 2 is being added. Ooh, so my first step is to subtract that 2 from both sides to give you a 4 over here, and then we're left with an a divided by 4 over here. And now we're down to a one step. The way you undo a division by 4 is with a multiplication by 4. 4 times 4 on the left is 16. 4 divided by 4 reduces down to a 1, which gives us just our a. And if you wanted to plug it back in and check, we could take these two over here and see if we get a true statement. So I will often put a question mark when you're checking your work. Do I get a true statement? If I replace a with 16, what happens? Well, 16 divided by 4 is 4. 4 plus 2 is 6. Does 6 equal 6? Winner, winner, chicken dinner. It does. Yippee. Moving on. Let's do another one. Number 3. So here my variable x is right about there. The closest thing to it is the 9. The next closest thing to it is that negative 7. So we are going to get rid of that negative 7 first. You undo a subtraction by 7 with an addition by 7. So if you're going to add 7 on the left, those 7's cancel out to be 0 that time. This is just left with a 9x. And look at this. Negative 7 plus 7 also turns out to be 0. Interesting. But x is still not isolated. Technically, it's being multiplied by 9, so we will undo that with the division by 9, dividing both sides by 9. Those will reduce down to a 1, and 0 divided by 9 is 0. It's like if you have 0 teddy bears and you want to share them with your 9 friends. You can't share any. Oh, sad panda. And some people get weirded out by having x equals 0 as a solution, but I mean 0 is just a number, just like we got 16 from before. Let's move on down to number 7. Here we go. So here a variable is v, and again, this one is kind of like the first one that we did. Anytime you see a division bar, you're talking about a fraction, and your mind should organize that as a group. And here, going back up, the division bar was just between the a and the 4. The 2 was off on its own. This one's different because that division bar is longer. It's v plus 9 divided by 3. So really there's kind of 2 sets of division bars in my head. Anytime you have a fraction, the top is its own piece and the bottom is its own piece. So really we're looking at v plus 9 divided by 3. So in this case, since that division bar is so long, that 9 is now the closest thing attached to that v, and the 3 is the furthest thing away. So if you wanted to undo the furthest thing, the way you undo a division by 3 is with a multiplication by 3. On the right-hand side, that's really nice, that's 24. On the left-hand side, again, that 3 and this 3 will reduce down to a 1, and anything multiplied or divided by 1 is whatever that anything is. In our case, v plus 9er. Next step, we're going to undo that addition by 9 with the subtraction by 9. And 24 minus 9, I think it's about 15. Wow. We did it. And the last one I want to do is, we'll say number 12. So now this one, I kind of was a little cheeky on you guys. This one is more than 2 steps, unfortunately. Here we have our parentheses again. So when we're looking at parentheses, we want to start on the inside. We cannot combine x plus 5 because they are not like terms. So there's nothing more we can do. Next, we look for exponents. There are none. And then we're going to look at multiplication division. Well, this parenthesis group is being multiplied by 12. The process for that is called distribution. So what we do is we distribute that negative 12, always take the sign with it, and we distribute it on through. I'm writing in red now, apparently. Negative 12 times x is negative 12x. Those just get multiplied. Negative 12 times positive 5. A negative times a positive is a negative. And I believe that's 60. And now we're back down to where we were. The closest thing to x is a negative 12. So I'm going to get rid of that negative 60 first. We undo a subtraction of 60 with an addition of 60. Those ones cancel out to 0, and I am actually running out of space, so I can extend page. Half a moment. Ignore this for now. This will end up being 204 equals negative 12x. And does that turn out to be really nice? 204 divided by 12 is negative 17. Oh, and on this step we divided by negative 12. A positive divided by negative is a negative. Those are some things that hopefully we'll come back to as we get going on this. All right, so your mission for the next few minutes is to work on as many of these as you can from the one-step equations. If you're feeling really comfortable with them, move on to the two-step equations. When you get done with it, then go up and go into Schoology and check your answers. It will be listed under our class under materials. And if you have any questions, make sure you take a note. My mission is to help you guys get through this, so really just ask questions, and I will help you out. Once you get done with that, then we will move on. Thank you so much.